Imagine standing on a planet where the wind does not just whistle, it rips through the air faster than a bullet. A place where atmospheric pressure would crush you instantly, and the temperature would freeze your very atoms. This is not science fiction. This is the reality of Neptune, the most distant giant in our solar system, and a world that challenges everything you thought you knew about extreme weather. Why does understanding Neptune matter to you? Our quest to comprehend such extreme conditions pushes the boundaries of physics and reveals the true power of cosmic forces. What if Earth faced similar, unrelenting gales? Neptune, a blue marble far beyond Saturn, far beyond Uranus, floats in the icy dark. It is so remote that even light from our sun takes over 4 hours to reach its frigid atmosphere. Yet, this serene, distant giant hides a violence few terrestrial storms can ever match. Its winds do not merely blow. They scream at speeds reaching 2,400 kilometers per hour. To put that into perspective, the speed of sound here on Earth is a mere 1,235 kilometers per hour. That means Neptune's atmosphere is a chaotic symphony of supersonic gales, a maelstrom constantly reshaping its own face. You might wonder, how can a planet so utterly cold generate such unimaginable fury? What kind of engine powers these incredible atmospheric rivers? What forgotten secrets does this blue titan hold? For centuries, Neptune remained a ghost, a mathematical prediction long before it was ever seen through a telescope. Astronomers noticed Uranus was not following its predicted path, hinting at a gravitational tug from an unseen neighbor. This invisible force pulled and pushed, twisting Uranus out of its expected orbit. Therefore, brilliant minds like Urbain Le Verrier and John Couch Adams independently calculated the exact position of this hidden world. On September 23, 1846, thanks to their painstaking work, Neptune finally revealed itself. But even as it appeared, the planet remained an enigma, a beautiful blue eye gazing back from the ultimate frontier. It was a triumph of human intellect, a deep dive into our ability to comprehend the unseen. However, the mystery of its extreme winds only deepened as we learned more about its composition. Neptune's striking azure hue comes from methane, which absorbs red light and reflects blue back into space. Beneath this blue veil lies a dense atmosphere, primarily composed of hydrogen, helium, and a small percentage of methane. Far deeper, you would find a slushy, superhot ocean of water, ammonia, and methane, often called an ice giant for good reason. This is not the solid ice you know. This is a supercritical fluid, a strange, viscous blend under immense pressure. But it is within the upper atmosphere, where temperatures plunge to a staggering -218 degrees Celsius, that the true drama unfolds. You are experiencing conditions so alien, so extreme, that earthly physics seems almost quaint by comparison. How do these unimaginably cold gases erupt into such a violent, supersonic dance? The answer lies not just in the cold, but in the heat and in the planet itself. Unlike Jupiter and Saturn, which are mostly gas, Neptune possesses a substantial internal heat source. Scientists are not entirely sure of its origin, but it is thought to be residual heat from its formation, or perhaps heat generated by radioactive decay within its core. This internal energy creates convection currents, pushing warm gases upwards and pulling cooler ones down. Imagine a giant planetary convection oven, but instead of baking, it is boiling. This heat, combined with the planet's rapid rotation, creates the powerful Coriolis effect. This force, which deflects moving fluids on a rotating sphere, helps organize these vertical currents into powerful eastward-flowing jet streams that dominate the atmosphere. There are no mountains, no land masses to slow them down, no friction to dissipate their energy. Therefore, these winds are free to accelerate, picking up speed unimpeded across the planet's vast, featureless cloud tops. The most famous atmospheric feature observed on Neptune was the Great Dark Spot, a massive storm system comparable in size to Earth, Voyager 2. the only spacecraft ever to visit this distant world, captured stunning images of this colossal vortex in 1989. This was a temporary phenomenon, unlike Jupiter's more stable Great Red Spot, when the Hubble Space Telescope later observed Neptune. The Great Dark Spot was gone, replaced by other, smaller, transient storm systems. This tells you something profound about Neptune's atmosphere. It is dynamic, constantly changing, and violently active. It is not a static canvas. It is a living, breathing, tempestuous entity. What causes these colossal yet fleeting storms to form and then dissipate? It is a puzzle that continues to challenge our understanding of planetary weather systems. Neptune is not alone in its extreme conditions. It has a fascinating collection of moons, the most notable being Triton. Triton is unique in our solar system because it orbits Neptune in a retrograde direction, meaning it travels opposite to Neptune's rotation. This suggests Triton was not formed with Neptune, but was instead a captured object from the Kuiper Belt. This captured moon is also one of the coldest objects in the solar system, with a surface temperature of -235 degrees Celsius. Yet, despite this extreme cold, Triton exhibits cryovolcanism, erupting nitrogen, ice, and dust plumes kilometers into its tenuous atmosphere. You are witnessing an object so cold it erupts frozen gas, not molten rock. How can a moon so frozen still be geologically active? This points to internal heating, perhaps from tidal forces exerted by Neptune or residual heat from its chaotic capture. So, when you piece it all together, the violent supersonic winds of Neptune are not just a strange anomaly. They are the inevitable result of a precise, extreme combination of factors. A planet formed in the deep cold, retaining immense internal heat, rotating rapidly, and lacking any solid surface to break atmospheric friction. This creates a high-pressure, low-temperature cauldron where the gases are driven into an unrelenting supersonic torrent. Neptune is not merely a distant blue dot. It is a profound lesson in astrophysics, demonstrating how even in the most extreme conditions, the laws of physics elegantly orchestrate breathtaking phenomena. The question of how such a cold place could be so violent is answered by the unseen furnaces within. You now understand that what appears calm and distant is, in fact, one of the most powerful weather systems imaginable. It is a world of silent fury, an unparalleled engine of atmospheric force. If humanity ever develops the technology to colonize another planet in our solar system, would you prefer a world like Mars with its relative calm, or a wild, untamed frontier like Neptune, even if it means harnessing its terrifying power? Which path offers more for the future of exploration? Let me know your thoughts in the comments below. Do not forget to subscribe to SpaceRepo for more journeys to the extreme edges of our universe, where knowledge is always pushing the boundaries.